Hello, my name is Daniel Houston, and this is my Lab 1 charged tapes. In this lab, we'll look at two pieces of clear Scotch tape and see their charges and the transfer of electrons. Alright, so some of the assumptions we're going to make for this lab is that we're going to ignore the air resistance because it has no impact on the pieces of tape. Additionally, we're going to look at the pieces of tape as point charges, and then the charges are going to be evenly distributed throughout the pieces of tape. And these are the fundamental equations that we're going to use throughout this lab, specifically for Coulomb's law, the electric field, and the relationship between force and the electric field. And these are pretty self-explanatory, so I'm not going to go into too much detail. Alright, so for the setup for this experiment, the length of the tape is going to be 20 centimeters, and then the mass of the tape will be 0.0002 kilograms. And then the measured distance between the two pieces of tape is 0.0258 meters. This is some of the code that I used for the computational models, and as you can see in this first section we have the constants and initial values, which are important in establishing the rest of the equations, and then below that we have the gravitational electric forces, where the gravitational force is mass times the gravitational constant of 9.8, and then the electric force is just equal to the gravitational force. In the next section, in the top right corner, we have the charge of the tape, which is a simple calculation, and lastly below that we have the calculation for the electric field, which is just a method that uses the equation for the electric field. This computational model both gives us a diagram and a few important values to take note of. The first one being the gravitational force at tape B, and then it also gives the electric force on tape B and tape A due to the opposite tape. Additionally, we have the charge of tape B and the electric field at tape B, all shown here. And these are a few additional calculations. This is the calculations for the charge of the magnitude of B, and you can see here that when you set the gravitational force equal to the electric force, that you can then solve for the magnitude of B. And this shows the calculations that I used for the area of the tape, the number of the atoms, number of the electrons, and then the ratio of the electrons to atoms. Now, what if we were to change the charges of the electrons and the protons? So if the electrons had a positive charge and the protons had a negative charge, what would change about the observations that we made and the other charges? Well, this would actually cause nothing to change within the experiment because the observed behavior would still be the same, it would just be different notations. So like charges would still repel and opposite charges would attract. Why is it important to handle the charged tapes as little as possible? What happens when charged tapes come into contact with your hands or other objects? Well, once the tape comes into contact with any objects, the electrons are free to move to those objects, and this could actually compromise the charge of the original tape. And so this requires us to try to handle the tape as little as possible in order to make the charges as accurate as possible. Thank you for watching my Lab 1 video.